All right. One thing is sure, in the real world of data, data is often messy, right? And this is one of the things we've always mentioned right from the days of Excel, right? That in the reality of data, data is often messy, often dirty, because it's subject to a couple of things, right? And in this particular time, well, what we're about to enter now is how to handle this data very nicely. But one of the benefits of using pandas to handle missing data is the fact that you can handle large data sets very fast because pandas can process all of this data very fast for cleaning, right? And just this year, listed there are some options that we can use to maybe do some data cleaning or handling, let's put it that way. And we'll be exploring them one after the other. Okay, so let's say we want to create a data set first. So create a data frame, because if we look back at what we used just here, everything seemed clean. All right, everything seemed clean. I think at this point, yeah, this is data I've been using. Our CSV file seemed clean, no missing value in there. Okay, so we'll just create one here, call it df. Let's say df missing. Then we'll open pd first, pd dot data frame. Pay attention, it is Pascal case, capital D, capital F. Don't get frustrated if you miss something like that. So just correct it. It can be very frustrating and you just feel like you're getting an error but you're typing the same thing. Okay, you really want to pay attention to that. So just do something simple. A, so we're passing the dictionary. Then we'll say B. Then we'll say C. Let's put that in quotes. Right. Okay. So we'll pass in the list. 1, 2, MP, mp.nan, and 4, put a comma. Then we'll say 5, mp.nan, 6, okay, this is 6, 7, 8, we'll add another comma, open a square bracket, then we'll say 9, 10, 11, np.nan. Okay, so passing, okay, nan is nan, all right? So we're passing this, and we're intentionally creating values like nan, okay, in our data frame. And of course, we want to see it printed down here. So say df underscore missing. No, not this, missing. All right. So I'll just use Alt Enter so that it can create a new code cell for me at the bottom. All right. So you can see this is what we have. And why are we seeing this underlined, this yellow line? It's just probably because we're not printing it out properly. But the print field is not so friendly. It makes it look raw, right? You can see we're having it look raw like that. So just leave it this way, and we'll move on. Now we see that, let's rerun that so that we'll have the field vibe. All right. So the next thing we want to do now is to start cleaning our data. But before we clean the data, we have to know or find out if it is, or if it has missing values or not, right? If it has missing value, we want to find out first. If it doesn't, then that's fine. So how do we find out if a data has missing values? We can use is NA, is null, right, to check if our data has missing values. All right, so let's do that check quickly. And just say print. We can just put a print directly, a formatted string, and then we'll say as missing values, and in there we just let's do \n, so it prints on a new line. Then we'll say df underscore missing, then we'll say dot is null. Okay, dot is null. So we want to find out if there are missing values in our data, right? This is not a number, okay, not a number. So let's print this, and it's saying okay, so it has checked the entire data set and it's saying false, false, false. So not a number as well, true. So you can see that for column B, row label 1, column B, row label 1, which is this place and this place, we have what? We have true. Also for this place, row label 2, column A, we have true. And finally for this place, we also have true. So we can see that, oh, we do have missing values in our data, right? We do have missing values in our data. We can get the total of the missing values in a column, right? How do we do that? I just copy this, paste here, and then we do a okay. So we're saying is null. We're just adding sum to it. Number of missing values. So this time we'll put it as a colon. Alt enter. So you can see for total column A, all the column, you can see it is by column. So we have one missing value. For B, we have one missing value. For C, we have one missing value. By the way, if you're wondering what the difference is between is null and is any, they're basically the same thing, okay? Is null came first, right? Is null came first. Let me just put it this way. Is null came first, more like the SQL style, right? Then later is any or came. So if we just change this now, if I copy this and then use is any, we'll get exactly the same thing, no difference at all. Okay, so I'll use Alt enter. You can see exactly the same thing, and we can also do it for the sum as well, so it can be used interchangeably. All right, you can see just like that. So now we have checked if our data has missing values or not. Of course, if you think back, when we're looking at or inspecting the data, you will know when we're trying to know the data, you remember that there is one method we can use to get the number of missing value. One of these when we're inspecting data, which we covered, I think, just right before this. Yeah, data frames. Okay, I broke this. Continue here, this part. So just right before this, you can see we can also get the total, but we have additional details in here. If we don't want the additional details, just go ahead with what we use, which is the is any or is null. All right, now that we know we have missing values in our data, I'll just add more columns. Okay, so now that we have more columns, now that we have figured that we have missing values, so we probably want to maybe drop. We might say we want to drop the entire row for a missing value. That's if, now we must be careful of dropping records, because if we're dropping the records, which is a row, and we have many missing values in a row will probably drop too many data, and this will not be good for a machine learning model eventually, because the more data we feed it with, and the more, let me use the word, the more good data, the more clean data we feed it with, the better the result we get. Okay, so but I'll just show you, if we were to drop the rows, what it will look like. Okay, if we were to drop the rows, what it would look like. So let's just do that quickly to understand how to use the drop to take out missing rows, just in case you want to do this at any point. So just a df underscore, let's call this dropped rows, dropping drop rows with missing values. Okay, so drop rows, then df underscore missing, then we can say drop na. Okay, just say drop na, and with this, take this down, and with this we can print out the dropped rows. So just say print f, let's say data frame after dropping NAs. NAN, just like that. And so I just want to put it down here so it looks drop rows. Right, so you can see that this is all we have left. Now intentionally we use the variable y so that we don't overwrite the original table, because if you look at this now, we should still have our full record in there. So but because so that's why we saved it, we didn't overwrite this completely. Okay, we did not overwrite the drop any directly. So if we wanted to do that, we can pass in a value called in place, and if you look at this, it takes what? In place. I'm passing an axis if it's just now if we pass in an axis, so we tell it if it's a row or a column. Okay, and then we can put in place just like that. So I'll remove this. This is the version of what we have after we have dropped the rows. Okay, after we have dropped the rows. What if we want to drop a column or instead of a row, right? So sometimes you might want to take out columns, not because they have missing values, but because they'll be relevant to our what's it called, to our analysis. Okay, or they'll be relevant for the machine learning model we want to feed them into. We can easily do that by using the same drop that we just used, but then in this case we'll be passing an axis. Okay, so I'll just copy this, Ctrl C, Ctrl V, dropping columns. Okay, so let's drop the columns with missing values. Right now, once we say df, this is the variable we had earlier, right? Df underscore missing, then we'll say drop any. The only argument we have to pass in, like I said, if you overrun this drop, you can see we can pass in the axis, right? And we can also pass in place. In place is if you want to override the original variable, but we don't want to do that. Okay, and that is why we are saving it inside another variable. This is not PDF, df. So we'll just say axis equals to 1. 0 is for row, 1 is for column. So we say axis equals to 1. Then if we want to pass in the in place, we can pass it in. So we'll just remove this, and the next thing we want to do is to print it out. So just say print, and we'll put dropped df.dropped. No, oh, rows. No, this should be columns. Calls. Let me change this as well to calls. Columns with it's missing values. All right. Let's run this, and now you can see that we just have the index left, because basically all the columns have a missing value or the other. If you look at this list, column A has one missing value, column B has one missing value, column C has one missing value. So basically all our data is gone except these labels right here. See, everything is gone, but we still have our original data, however. So let's print our original data down here again, which is df underscore missing. So you can see our original data is still here. Okay. So the next thing we want to do now is, let's say we don't want to delete them. We want to fill up the values. We want to fill up the values. How do we do that? And do that here. Filling missing values. Filling missing values. Okay. So we can fill with specific values. For example, we can fill with zeros. We can say df filled zeros or 0. All right. Singular plural. Then we'll say df underscore missing dot fill any. The way we have drop any, we also have fill any. Then we pass in our value in here. So you can see it says value. So passing our value in there, just like that. So it can be a scalar value, it can be disk type, any type, it can be dictionary, it can be series, it can be data frame, whatever it is we want. So we have passed it in, okay, and then we can print it out just to see df filled with 0. All right, so that's df filled 0. We don't need to put any special prints there. You can see it has filled everything directly with zeros, just like that. Now it can happen that we probably want to fill with the average of that column, right? It's possible that we might decide to fill with the average of a column, right? How do we do that? Fill with mean. Mean is the same as average, okay? So fill with mean of the column. So we can just say df filled mean, then we'll say df the missing, df underscore missing, I mean that's our variable name. So df underscore missing, then we'll say dot fill any, say dot fill any. If you over on the fill any, all right, that's just the network. Let's wait a little. See now. Okay, let me type that again. Fill any, and over on it. I just want the documentation string to come up, but let's continue regardless. So in this case, we'll just say df dot missing, df underscore missing, I keep saying dot, df underscore missing dot mean. Okay, so we're passing the mean. Now we can pass a variable called numeric only. Okay, since we are trying to do it across the entire data, so we can say numeric only, and you can see it right here, numeric only, and that will be true. So we'll say true. Okay, so numeric only to be true. So we'll say df dot field mean. Okay, so df dot field mean. Yep. Then we'll execute that. Then we can see. So it checks. Now for the column, look at our original data and print our original data down here. df, we don't have any data like that. df missing. Okay. So you can see here we have 7, right? Then when we if you check the average of those 3 numbers, that's 1 plus 2, that is 3, 7 divided by 3, that should give you 2.33 that you have here. This is 20 divided by 3, so more like 21, 7, so that's 6 point something, and that's what you have right here. And for this is 30 divided by 3, so you're getting an accurate 10. So it's able to fill the column, individual column, with their mean. However, what if you just want to work on a single column? What if you want to work on a single column on a specific column? Specific column. So if you want to do the replacement on a specific column, that means you have to say, let's say df field column C, let's say column, let's start just to column B, random column. So column B, then we'll say df underscore missing, then we'll pass in B, right? So we're saying for this particular column, fill any, and what is it going to use to fill the any? We want to use the value of that same column, right? We want to use the value of the same column B. So just say df underscore missing B, just like that. Then we'll put dots mean. Okay, so let's print this. Just put it down here, df. Okay, I think we can bring that up into a separate column. Paste here. Then we have df field column B, and you can see if you look at it, it's exactly doing exactly the same thing, right? What if we want to fill for a text column? Because I've been working on a number column. What if we want to fill for a text column? So we can just say df underscore missing, df underscore missing. Let's create a new column. Then we'll just say this column will be D. So let's say D. Then we'll just say mp.nan. mp.nan. So if we print the df underscore missing, now So add a couple of that. df underscore missing. So you can see we now have a new column called column D. So let's say I want to fill column D with text, right? I want to fill column D with text. So we can say, just like as the ones we have done, it's no different from that. We just do our same D fill. So they filled texts D. So that's for column D. So we can say df. Now since we are working with a specific column, so we'll say df underscore missing. Now do not forget that for us to do that in this place, we saved it into another variable. But if we want to overwrite it, we have to put in this variable on the left. Okay. But since we are not overwriting our original array, we'll just say d. No, we don't have s. It's a d dot fill na. Okay. Then in here, all we want to do is passing column D. Let's just pass in a text. Column D. And then we'll do df field. Not this text. Okay. So we're saying fill that column with a text. So it's showing column D, column D, column D. That's just it. We're only working with a single column. So it's showing all column Ds. What if you want to work with two different columns at a single time, right? And say df field multiple. So say df underscore missing dot fill na. Now in here we'll pass in a dictionary. Okay, and then we'll say let's say for the first one now, which is going to be a, capital A. Let's create two new columns. We can create for, okay, we'll fill in C again and D with another value, right? So fill in C again and D with another value. Since we already have, I hope we created this on the original array. Yeah, column D is on the original array. So yes. What do I mean by that? If we look at our df missing, the original df missing, oops. So if we look at the original df missing, you can see our D is still there with the nan. All the nans where we have them are still right there. Okay. So pass in the first column, which is C, and this is a dictionary, right? So we can expand this so that it's you can see it more properly. So say C, go back up, then we'll add a column. What value? So C is the key, right? If you remember the dictionary vibe, C is the key. What do we want to replace C with? We want to replace it with df underscore missing or column C. I want to take the mean of column C itself. Then mean, open and close. Take this out. Nope. Take the extra quotes here out. All right. And this is a dot, not a comma. Then we'll put a comma down here. Then we'll say for column D, let's say we want to pass in the value empty. It could be a text, it could be a number. Now this one is an operation, this will be a text. Empty. So this is what we want to pass in for column D. So we can say filling multiple columns with different values. Multiple, okay, multiple columns with different values. So we can come down here and say df underscore field multiple singular. Okay, yeah, this should be fine. And you can see just like that. It filled this correctly. It also filled this correctly for us. Okay. Okay, so we'll do the forward fill and we'll probably just get a warning because this is the way it's supposed to be. Let's just check that out. All right, that's correct. And you can see what we have. So we did a forward fill. This became 2, this became 5, this became 11. So let's try that with a backward fill and see what it's going to look like. So I can just copy this, then I'll paste right here. So by the way, we're getting a future warning that df fillna with the method is deprecated and will now raise in future version. That means in the future version, we will be getting, what's it called, an error. It will be raising an error. It will be raised as an error, but now it's just a warning. Okay, so and the way we do it now is what, we don't need to put .fillna. We just put the object itself, which is this, and then we'll do .fill, backward fill, forward fill, and that's what we'll do for this one. So say bf, then instead of fillna, I'll just take all of this out and then do a b fill, right? Then this is all. So now print out the underscore b fill, then we'll run that, then we can see what we're getting. Now because there's nothing in front of this, there's nothing to fill it with, right? You can see earlier this was 2.0, this is 4.0, right? This 2.0 is now doing a backward fill, so it's now 4.0. This, it was 5 here, it is 7 here, and this is just n here, right? There's nothing to fill it with, and in this case there's nothing to fill any of this with because there's no valid value in column D at all. Okay, there's no valid value in column D at all. And yes, with this, I think we've quite covered much how to undo missing values in a data using Python. Yeah, so I've covered how to undo missing values in data with Python. And of course, sometimes we'll have duplicate values. So we have seen how to undo missing values. Sometimes we'll have duplicate values. This should have been like tagged data cleaning or something, but it's okay. So we want to see how to undo duplicate values in the data. Okay, so I'll just list them out as we do not have a data set to demonstrate them yet. So let's just assume we have a sample data df or df dupe, right? So to use it with this data set df dupe, all we have to do is, for example, to first check the same way we did for his na, we say df dupe dot duplicated. It is a past tense, right? Duplicated. This should be duplicated. Now we'll say df dot duplicated, and for us to do so, this will check boolean true or false. Checks for duplicate. Checks for duplicate. Okay. Now, what if we want to drop the duplicate? Of course, we can drop it inside a variable, as we have always seen. I mean, we can drop the result after dropping the variable. What I mean is this. Let me just clarify that. I mean, just like we have been doing this, right? All the operations, we have been saving the new operations inside another variable. Exactly. So that is what I mean by that. So we can say df.dupe, then we can say dot drop duplicate, dot drop duplicates. Now this is plural. Hold on, I didn't mean to run that because we don't have this variable. So I'll just like clear. Okay, so say dot drop duplicates. Just do shift, removes duplicates across all rows. Okay, this is an all row duplicate remover. Okay, now if you want to remove duplicates across specific columns, you can say df underscore dup, then we'll say drop duplicates again. Just copy and paste. Okay, drop duplicates. Inside there, we'll now pass in an argument. Let's see if the doc. Okay, doc is not coming up. So in here we can pass in subset. Then we'll pass in a list of the columns we want to check on. In this case, we'll be passing in a list of the columns we want to check on. So we want to say full name and the age. Okay, I want to say the full name and the age. So drops by specific column, by specific columns. Okay, and finally we can keep the last duplicate value we find. Okay, so we can use this on either a column or for the rows. The only difference is to keep the last row. Let's just say id, for example. id, for example, we'll say keep equals to last. By default, it keeps the first. So if you want to keep the last, we say equals to last. Control C. If we want to remove both of them, that means all the occurrences. By default, it keeps the first one, and then any other thing that repeats, it takes it out. But in some cases where, for example, it's duplicated due to updates in value, of course, that will be because of the system design or the data system design, whereby, okay, someone updated their email address, so it duplicated their entire record. But the latest one is having the updated record. So in that case, you might delete the previous one. So you can say delete first, right? So keeps the last duplicate dupe found. Yeah, keeps the first. Keeps, let me just put default because that's the default. Keeps the first. And finally, if we don't want to keep any of that, you can say keep is equals to false. All right. Okay. Then we'll say removes all occurrence of duplicates. Okay. So this removes all the occurrence of the duplicates. Okay, for some reasons I feel it's best we demonstrate it. So let's just create a data frame for it. Then we'll say df equals to pd dot data frame, open a bracket, then we'll pass in a dictionary. Undo that, pass in a dictionary, then we'll open it up. So we can just say name Alice, Bob, Alice Charlie, Alice Charlie, let's say Alice again. Alice, Darwin. Oh, Alice 1, Alice 2, Alice 3. Alright, let's also repeat Bob for once. Alright, so this is what we have, and we'll do dot split so it becomes a list for us. I'll put a comma, then we'll say age, and we can put in 25, 30. Alice is 25 again, 25 again. Then we can do Charlie. Charlie should be let's say 35. So we have to match it. So Alice 30, Bob 30, Alice 25, Bob 30, Alice 25 again, Charlie 35. So Alice again, Alice is still 25. Alice is 25. So Darwin can be 40. Darwin can be 25 too, by the way. Darwin 40, and Bob is the second person, 30. So let's look at it. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, that's correct. Then we'll put a comma. Then we want to say city. We'll just use some US city short code, NY, LA, LA. Then we'll say NY again, because that's for Alice again. Then we'll say CH. Then we'll say NY again. Then we'll say SF. Then we'll say NY again. No, would that be NY again? No. So this is Alice, Alice, Bob, Bob, Alice, Alice, Charlie, Alice again, Darwin, and then Bob, right? So the last one will be for Bob. So we can just put Bob for CH as well. Okay. All right. So let's print this out to see what it looks like first, and then we'll say DF. And we'll see what that looks like. Now we can just do DV or PX for this guy. Let's do DV. Okay, so it kind of match except for this. Oh, we're having an error there, so that's data frame. Okay, so this should be perfect now. All right, and this is what we have. Okay, this is what we have. Name, age, city. So let's add some code cells. Now the first thing we want to do is to check if there are duplicates. Now in this case, since you don't want to start creating variables and overwriting them, we can just print them directly. So just do print, or do df dot duplicated, because we want to check. So duplicated, and like I said, it is past tense, not duplicate or duplicates. So run that. Hold on. You can see what we have. False, false, true. That means third row is a duplicate of the first one. True, duplicate of another row. Then we have false, false. Okay. Bob. Oh, I used DV for Bob. This is the person I wanted to use DV for. So you can see that it is checking the entire row, right? That's the first thing. Before I change it, you can see that it is checking the entire row, because Bob here is 30 but stays somewhere else, right? Bob here stays somewhere else. I think it's cool. We can just leave it that way. So NY is duplicated. All right, we're good. We're good. Now let's say we want to remove duplicates now. if we draw duplicates, do df dot drop underscore duplicates. Okay, just run that, then we'll execute. So you can see it has removed duplicates for us clean. So we removed Alice, or the repetition of Alice. We're only having Bob again because it is not an entire row duplicate. Do not forget that in removing duplicates, we can do row duplicates or column specific duplicates. Okay, so it has removed the ones that match the entire row. Okay, so what if we want to remove specific column specific duplicates? Right, just copy this, make it faster. Now paste here. Now say in here, so we're passing what? Subset. No, it's not correct. Sub has, oh, nope. Subset. Okay, and you can see that automatically came with the equal to, then we'll pass in a list. Then we'll say we want the name, comma, the age. Okay, so we're dropping duplicates on these two columns. Let's run that. And now you can see we don't have the second Bob anymore. So we're checking duplicate based on the first two columns. And you can see how simple it is to do. Right? How simple it is to do. So we can now do the keep last, keep first, keep this, keep that part of it. And say we don't want to keep any of the duplicates. So let's see how, if we don't want to keep any of the duplicates at all. So Control C, Control V. Let's say keep equals to false. So I'll leave you to try keep first, keep last, so that you see how that looks like. And you can see all the instances of the duplicates are gone completely, right? So feel free to put in first here and last and see what that looks like for you. So with this, we've covered handling duplicates. So close that, and now we want to move to data type conversion, which is still part of our data preparation stage, right? Because when you get data, you want to find out what is in your data, you want to clean it, you want to make it ready for analysis. You want to make it ready for analysis. Okay, so let's jump into it. Now, ensuring our columns have the correct data type is very important for memory usage, right? Very important for memory usage, but much more for analysis, because if the data type is wrong, we will not be able to carry out accurate analysis, right? We've seen how null values, I think when we're looking at NumPy, we were trying to take a sum of a column with null values, and then it's just not letting us do that, right? It's not letting us do that. So data types are important, and somehow I feel we've covered text string manipulation or so, but no, I don't think so. We haven't done that, not even in the basic module. So let's just continue. We want to see how we can convert from one data type to another, because most times we don't determine the data type, right? We don't decide the data types that come with the data. So but we can correct it when we need to. Okay, so just say data frame for types. Then we can create a dictionary again, pd.dataframe. A 1 2 3, B, let's just do 1.1, 2.2, 3.3. Then we'll split it. Dot split. That'll give us a list as well. Then finally, we want C. We want a boolean in this case. By the way, it doesn't matter. You can use double quotes. You can use single quotes. So let me use double quotes here. Okay. Finally, we want a boolean. So say, since we'll split them up, we'll make it a text first. So say true, false, and true. Okay. Then we'll also split it up. Okay. So let's bring this data type to see what it looks like. Okay, so you can see what we have. But everything, obviously, from the way we created it, is a text, right? Everything is a text. So let's add some new code cells. So if we check df underscore types dot info, so you can see only the first one is an integer. The remaining two are objects, right? See, integer, object, object. And the second one is supposed to be a float, while the last one is supposed to be a boolean, right? Last one is supposed to be a boolean. So let's see how we can correct all of this with Python. So I'll take this out, clear the cell output, then we'll type in right here. So say df underscore types. We've had a lot of dfs. So df underscore type, like I said, this is supposed to be a float, but it is individually string. So I want to say df.type, then colon b, because we want to overwrite it, right? We want to override the original variable. I'll say df underscore types. In quotes, put in b again. Then we'll say dot as type. All right? So passing as type, and it takes what? Since it takes the data type we want to pass it as. So just put in there, we'll say float. So now we can print the data type df df underscore d underscore types, okay, dot d type. All right, so we want to check the data type after converting it, and you can see the now is now what? A float. Earlier we have it to be an object, just like this. So you can see it has now converted it to a float. So we want to do the same thing for boolean, which is easy. And just copy this, then we'll paste it there, then we'll say c, then we'll convert it to what? To bool, then we want to print the types again. You can see it has now converted it to a boolean. Okay, so we now have it as a boolean. So let's say we want to do some let's say some conversion that we need to handle error. For example, we want to do a numeric conversion. We can use the coerce to suppress errors that cannot be converted. What does that mean? Let's look at it. So let's say df numeric underscore error. So we have pd dot data frame Just want to pass in something simple. So just say column, but it's just a single row data in a way. So I want to say 1, 2, ABC, 4, np.nan. Okay, so we have all of these values. Okay, so if we print this down here, df numeric, okay, df numeric error, and you can see it's just a single column, right? Just a single column of data. So we want to be able to convert this error from what it is, right? I want to print it out. So let's see what that looks like. We'll say df underscore numeric error, then the column, say equal to pd to numeric, then in brackets passing the column, df numeric error. We have just a single column, by the way. Now this is what we want to convert. Then we'll run this and see what it will look like. Okay, df numeric error. Okay, so you can see what it's saying. It's saying, oh, I'm trying to do what you want me to do, but I cannot pass this as a number. I can't seem to do that. There's no way I can do it. So we want to be able to undo that error, right? So we have the coerce option to undo that. So we can say errors. So we'll go back to this place now. Let's look at PD numeric. So you can see the first thing is what we want to convert, and then the second thing is the errors. So it says the error. So right here we can say comma. Let's see what we're typing. Okay, and then we'll say error. So for the errors, we say we want to coerce it. So we'll say coerce. Is that how to spell coerce? Coerce. Yeah, that's how to spell it. So we'll run this again, and now you can see we have been able to successfully do that. So that particular one has been now passed as none. So you can see now we have undone that kind of error. So if there's a specific kind of error that can crash the conversion, it just passes it as not a number, because this is a numerical column. Okay, and what the word coerce simply means is to force, right? To use force, to force the attribute, the data type, to take on another one. But the word coerce itself means to use force, threats, whatever it is. Okay, all right, so let's collapse all of this. Our data type